Okay, in this question, it says a small craft in Lake Ontario sends out a distress signal. The coordinates of the boat in trouble are -15, 23. The Coast Guard's Moonlight 2 rescue boat is at the coordinates 8, -20, and the Coast Guard's Moonlight 4 is at coordinates 22, -12. Give exact answers to parts A and B. Part A says, what is the distance Moonlight 2 would have to travel to the boat in trouble? Part B asks, what is the distance Moonlight 4 would have to travel to the boat in trouble? And Part C, which Coast Guard boat is closer to the distressed craft? And it's a multiple choice. We can either choose Moonlight 2 is the closer rescue boat, or Moonlight 4 as the closer rescue boat, or we can choose neither. They are equally far away. So we don't need to graph anything to be able to answer this question, but it is helpful to at least visualize what we're talking about. And I always recommend students get in the habit of graphing, even when they don't really have to graph, because it'll help you understand what you're doing a lot more. So I made a picture. I used an online graphing calculator, but I would advise you to use actual paper and do this by hand. And I've drawn a line between the boat that's in trouble and each of the rescue boats. And just looking at them, it looks like they might be the same distance away. Maybe the distance to Moonlight 4 might be a little shorter. So I'm not really sure, but just visually, that's what I'm seeing. And the reason that we typically don't answer questions based on visual inspection is because things can be deceiving to the eye, and things can be just slightly different in size, even though they look about the same, or just the way it appears sometimes can fool you. So we use algebra to make sure we're getting an accurate answer here. And I'm going to start by finding the distance between Moonlight 2 and the boat in trouble. So that will give us the answer to part A of this question. Now I'm going to use the distance formula, but I don't really usually write it out, although I will write it out for you. I'm going to write it out how I like to write it out rather than using the book's definition. I always remember that the distance between any 2 points in two-dimensional space is found using the Pythagorean theorem when you draw a right triangle. Using the line segment that is connecting the 2 points as the hypotenuse of a right triangle. So just to show you what that would look like, I would draw a right triangle and try to line it up with the hypotenuse. That didn't come out the way I was expecting. Let me see if I can do that again. No, I'd have to mess around with it to get it just right. But you can kind of see right here how this side could be the leg A, and this side over here could perhaps be leg B, and then you could use a squared plus b squared equals c squared, and c could be the hypotenuse or the side opposite the right angle. And so you would just say that that distance of that line segment, the hypotenuse c, would be equal to the square root of a squared plus b squared. And so that's the formula that I always have in mind, but I don't really think about it that hard. I just remember that it's the square root of 2 squared sides being added together. So a squared plus b squared if it was the Pythagorean theorem. But to get the distance of the horizontal leg, I would have to subtract 2 x values. So what I'm going to do is I'm going to take the x value from the boat in trouble, which is -15, and I'm going to find out how far it is from the x value of Moonlight 2, which has a x-coordinate of 8. So to find the distance between two coordinates, we're going to subtract them. Okay, so I'm just filling it in there. Now to find the vertical leg, so we might think of it as B, we would want to subtract the two y values. So I'm going to start with the y value of the boat that's in trouble. So that's 23. And then subtract the y-coordinate of the Moonlight 2 rescue boat, which is -20. Now, I already know that I want to subtract 23 minus -20, which will give me a double negative, and that will mean that I end up with a plus 20. Now, it would be fine if you did this differently as far as the order of the coordinates. So I could have just as easily done 8, the x-coordinate of Moonlight 2, minus -15, the x-coordinate of the boat in trouble. And if I subtract -15, that'll give me a double negative. And that's what that would look like. Now notice that when I simplify -15 minus 8, I'll get -23. And then when I do -23 squared, a negative times a negative is a positive. So it'll become the same thing that I would get by adding +8 and +15 to get +23. And then to square that, it'll be positive, of course, because those are already positive. So it really honestly does not matter which coordinates you do first, just as long as you keep your x values together. And sorry, I had a little alarm going off in the background. Just as long as you keep your x values together and you are careful with your signs, right? And the same thing would happen for the y values. And just to show that, I'm going to go ahead and say, well, what if I started with Moonlight 2's y coordinate, -20, and then subtract the y coordinate of the boat in trouble, 23. So then that would give me -43 when I simplify it. -43 squared is going to give me the same thing as +43 squared, which is what I would have gotten with the first order that I put them in. Okay, so because of the squaring, it does not make a difference of the order. Okay, which is why I don't write out the formula. I just remember distance between the x's squared plus distance between the y's squared, and then take the square root of that. Okay, so now I'm just going to pause it while I do some calculations, because these are pretty big numbers. So we're going to have 23 squared plus -43 squared, and we're going to want to come up with those numbers using a calculator. I was going to pause it, but I guess I can just do it. Yeah, I'll pause it. Okay, so what I got is that 23 squared is 529. -43 squared is 1,849. And when you add 529 plus 1,849, you get 2,378. And then I thought, well, that's an awfully big number. I wonder if there's any perfect square factors that go evenly into that number. So over on the next slide, I just have it written here. We're going to simplify it. And then I started writing out all my perfect squares that I know by heart and thinking about whether any of these might divide evenly into this. Now it's even, 2,378 is even. So it made me think that maybe 4 would divide evenly in. And when I tried it, I got a decimal number answer. So that would mean that 4 does not go in evenly. So that means that I can now eliminate any options that have a factor of 4 in them. So when I'm looking at all my perfect squares, and like 4 obviously, we'll eliminate that. We tried that and it did not go in evenly. And since 4 does not go in evenly, and 4 is a factor of 16, then 16 will also not go in evenly, and nothing that has that is divisible by 4 would be a good candidate for this. So just getting rid of all those options. I think this one also, 2 times 7 and 2 times 7. Yeah, so all those are definitely not going to go in evenly. One is trivial. Then I tried 3. 3 did not divide in evenly, so nothing else that has a factor of 3 should be able to divide in evenly. So 9 squared should not be able to divide in evenly. And then I thought about 5 squared or 25. Well, anything that's divisible by 5 or any multiple of 5 would have the last digit would either be a 5 or a 0. So that that number is not divisible by any multiple of 5. So that eliminates this as an option. Then I tried 7 and I tried 11 and I tried 13. And at this point, I'm pretty confident that um, none of those, no perfect squares. I mean, I could keep going higher and higher in the numbers, but just based on, how if we just keep going higher and higher, most numbers are going to have um, a factor that's one that we've already tried. So I'm starting to feel pretty confident that this one is not actually simple. It doesn't need to be simplified because there's no perfect square factors. But it is an even number, so you could divide it by 2 and just sometimes that helps if you can't think of anything else. If you just start breaking it down by something you know works, and any even number is going to be divisible by 2. So that gave me 2 times 1,189, right? And that I thought, oh, maybe 3. No, 3 didn't go in. So you could keep messing with it. At this point, I just said, I think that's fine. And I put it in just like this, 2,378, the square root of 2,378, and it received my answer just fine. So moving on to the next piece, we're going to go here and now find the other distance between the boat that's in trouble and Moonlight 4. So we're going to do the exact same approach. We're going to take the square root of the sum of the squares of the distances between the x's and the distances between the distance between the y's. So the distance between the x's, just because I like to. I don't really know why, but I like to start with that trouble boat, -15. I guess because it's the leftmost point, and I like to read things from left to right, just like we read words and sentences and graphs for that matter. So I'm starting with my leftmost point, getting my x value, and I'm going to my x coordinate of the rescue boat, and I'm subtracting that, so -22. Then my y value. So the y coordinate of the boat in trouble is 23. And now I'm going to subtract the y coordinate of Moonlight 4, which is -12. And that double negative there ends up making it a positive. And now I just need to simplify these, and I'll do that with my calculator and come back briefly. Okay, so I have -15 minus 22 is -37, and 23 plus 12 is 35. Then in the next step, I have -37 squared is 1,369 plus 35 squared, which is 1,225, and you add those together, you get the square root of 2,594. And I did a similar process trying to see if any perfect squares might divide into that, and I figured out that it seemed like this is the most simplified exact answer that we could get. So now we've found the answers to part A and B, the distances of each rescue boat from the boat that's in trouble. And I also put those into my calculator to get the decimal approximation so that we can just think about them in terms of, regular numbers. Now, I didn't need to do that to be able to answer part C. Remember, part C is just asking us which one is closer or which one is the shorter distance from the boat that's in trouble. And since they're both the square root of a large number, whichever number under the square root is smaller is going to be the shorter distance. That should make intuitive sense, but even if it doesn't, if you just put the square root, take the square root of each number in your calculator, you would get a decimal answer for each of those. So for the first one, I got 48.76 approximately, and for the second one, 50.93. So that is confirming that the distance in part A is the shorter distance. So we would choose the answer Moonlight 2 for the boat that is closer to the distressed craft.